Unit 7, Part 1. Welcome to Part 2 of the course. I'm very happy if you're watching these videos ahead of schedule, referring to the schedule included with the syllabus, which gives you an indication of what videos you should be watching then. So if you're watching them ahead of schedule, I'm very happy about that. But if you're watching these videos in accordance with the schedule, you will have just finished Exam 1. You would have just done Exam 1, right, completing the first part of the course, which is on Units 1 to 6. And now we commence on Units 7 through 9. We commence on Part 2 of the course. And what we'll be doing now is proofs. So this is proof theory for sentential logic. So this part of the course, Units 7 through 9, is also sentential logic, just as parts 1 to 6 were. At the end of Unit 9, you will do Exam 2, and then we'll start Part 3 of the course, which covers Units 10 to 16, and then we'll be starting, for that part, we'll be starting an entirely new system of logic. Well, not entirely new, but a new system of logic. There'll be many things carried over from sentential logic, but we'll be doing predicate or quantificational logic, where we'll be, instead of using capital letters like A, B, C, D for our atoms, where they stand for simple sentences, we'll be carving up those simple sentences into parts, right, into propositional functions and names, and we'll be able to use quantifiers. We'll be introducing quantifiers in quantifier logic or predicate logic, and we'll be doing proofs for predicate logic as well in Units 15 and 16 towards the end of Part 3. And those proofs will use all the rules we'll be introducing here in Part 2, Units 7 through 9, starting on this chapter, Unit 7, on the rules of inference, but it'll be different logic then. Now, Part 2, Unit 7 to 9, we're still using the same logic, still sentential logic, but a different method of proving arguments valid. Before I get into that, just a couple of logistical points. In introducing the chapter and introducing this part, Klenk writes in italics and emboldened on page 114, "It cannot be emphasized enough that it is absolutely essential that you learn these rules thoroughly. You must memorize them or you will simply not be able to do the proofs." I would stress this usually when we had classes in person, because you do need to memorize them, and usually the exams I give are closed book, and you have to not only have memorized the rules, but also be very well practiced in applying the rules. I'll be talking a lot about the importance of learning how to apply the rules to particular arguments throughout the lectures for this unit. Your exams will be done via email, of course, like the one you may have just done, Exam 1. All the exams, since we're quarantined, the exam will be done via email. But nonetheless, it remains true that you must become very, very familiar with these rules, right? Even though the exams will be open book, you have a time limit, and the time limit will ensure that if you don't, for the exams, if you don't know these rules very well, if you're not very, very well practiced in applying these rules to particular problems, you will not pass the exam. Okay, you have to, Exam 2, it's only 3 units, only Units 7, 8, and 9. As you would have seen from the schedule, most units have 1 lecture devoted to them, but Units 7 and 8 on the usual schedule have 2 lectures, 2 normal 1 hour and 15-minute lectures devoted to them. So be prepared. It'll probably have lots of parts, this section, this unit, in terms of videos. Be prepared to work, pay a lot of attention to these units, work through them heavily. Every section is quite important. As Klenk stresses, it's absolutely essential you practice all of the exercises, work your way up from the easier ones to the hard ones. I don't think I've ever said, but a feature of Klenk's exercises is for each question has several parts, A, B, C, D, E, F, G, however many, and she works from easier ones to harder ones, and you should work up in that way too, right? Start with the easy ones, make sure you get a hang for how they're done, and then you can work up to harder, more challenging questions, which are the later letters. 1H, 1G, 1H, those are sometimes quite hard. Okay, often the ones I do on the board are very, very easy, and you'll be expected to do much harder ones for the exam because I'm just introducing you to the basic idea and how you do it and the method, and it's easier to present the method for easier questions, but you need to practice doing harder ones. All right, also in my lectures, in these videos for this part, I will be very much assuming that you have read through the chapter. This is true for all the videos and all the chapters, but it's crucial that you read through the chapter. I will not be able to cover everything in the chapter in these videos. Yet everything in the book is accessible, so make sure you read it thoroughly. I will be talking about the rules, but most of what I'll be talking about is how to apply the rules, how to go about solving particular problems, and so on, how you should be thinking this thing, right? I'll be stressing the form of thought, the way you think your way through a problem, talking a lot about working backwards and stuff like this. Won't be saying exactly the same thing as the text. I'll be going through it, drawing from the text, but the videos, the lectures, are meant to complement the text, okay? So you can't use the videos to replace the text. Read the book is the point. You must read the book, and I'll assume you've done so in these lectures. Okay, good. So part 2, what's it about? Units 7 through 9. Okay, so our task as logicians is to examine whether arguments are or are not valid, right? As I said in the opening unit, it's a normative discipline, distinguishing good from bad. Logic is a normative discipline distinguishing good from bad arguments, which the master concept is validity. We want to distinguish valid from invalid arguments. We have 2 different ways of proving an argument valid, right? So we culminated the first part of the course in Unit 5 with the truth table test for the validity of an argument form, okay? So with the truth table test, right, we introduced the distinction between simple and compound sentences. We introduced our symbolism for sentential logic, right? And we have our formulas. It was a truth functional system of logic which made possible the construction of a truth table. The base columns of the truth table exhaustively gave us all the possible truth value combinations of the elements, right? The sentential variables, the P, the Q, and the R. The base columns exhaustively list all the possible truth value combinations. And since every sentence in an argument, every statement form, an argument form is made up of statement forms. Every statement form is truth functional, whereby its truth value is determined entirely by the truth value of the components. Because that was so, the truth table allowed us to test an argument form for validity, such that when we examine our completed truth table, if there was no rows where all the premises came out true and the conclusion false, if there was none of them, we could say this argument form is valid. So that was proof of the validity of an argument form. In Units 7 through 9, we introduce a new method for proving arguments valid. It's the proof method, okay? So as Klenk stresses, it's a bit more creative, it's less mechanical. It is not a mechanical procedure to compute truth values as it was when you do a truth table, which makes it a little more frustrating, especially when you're starting, but also more exciting and more challenging. Do think of it like puzzles. I very much, I enjoy this part of the course much more. Doing proofs is quite fun. But eventually what we're aiming at is proofs. This Unit 7 builds you up to it, talking about derivations and justified steps, and introducing to the rules and all that. But we're looking to do proofs where, and most of the problems you'll have to do in your exam, as you'll see from your practice exam, what we'll be looking eventually to do, a proof is just, we have a vertical line, and we are given some formulas, right, like this, given a whole bunch of formulas, and what will be given a bunch of formulas as premises, right? So it's an argument. We'll be given these formulas as premises, so you're given them as if they are true, and you'll be given a conclusion, some formula as a conclusion, and what we have to do is apply the rules which will be introduced in these 3 units. So Unit 7, the rules of inference, top half of your inside cover, and then next unit, Unit 8, the rules of replacement, bottom half of the inside cover. I've talked about them a lot. In Unit 9, there'll be 2 more rules involving the use of assumption, called indirect proof and conditional proof. And that set of rules you'll have, and proofs are sequences of justified steps where we have to apply those rules, deriving or inferring a whole bunch of formulas, however many is required, a whole bunch of formulas by applying the rules to the premises and to all the other formulas that appear, aiming at the conclusion. And the conclusion will also be a justified step, the final step in the sequence of justified steps. I'll give you the definition of these in the next part. Getting to the conclusion. So what you have to do is look at these formulas, see the forms that are the rules in them. I'll elaborate on that at length, and provide a proof. Right? But that's another way. That's because the rules are all valid argument forms. Right? This proof will, if we do have a correct sequence where every step is a legal application of the rule, we will have proved the argument valid. We will have shown through a correct proof that the conclusion does in fact follow from the premises, right? So this is another way of showing that an argument is valid, okay? So that's what we're doing.